In this video, we're going to be building on what we learned in the last video, and now we're going to be talking about molar mass. So the molar mass of a substance is the mass in grams of 1 mole of the substance. So before I showed this picture when I was talking about 1 mole of something. This is carbon sitting here, a certain amount of carbon, and that certain amount has a certain mass. So for 1 mole of carbon, in this case, that is equal to 12 grams. So again, the molar mass of a substance is the mass in grams of 1 mole of the substance. So the molar mass has units of grams per mole. And here's another example of weighing it out on a balance, a certain amount of carbon. And the molar mass is a bridge between the macroscopic quantity of matter, which is grams, and, fix that typo, particulate level quantity of matter, moles. So we count particles by weighing them in the lab. So we, in this case, put some carbon on a balance. We calculate its mass in grams, and then we can calculate the number of moles it has and the number of particles, okay? We don't sit there and count particles. We'd be there for eons because there's so many of them. Okay, so the definitions of atomic mass, the mole, and molar mass are all directly or indirectly related to carbon-12, which leads to 2 important facts. Okay, the mass of 1 carbon-12 atom is exactly 12 atomic mass units. And that's something we saw before when we were talking about atomic mass units, I believe in chapter 5 or 11. And the mass of 1 mole of carbon-12 is exactly 12 grams. Okay, so its molar mass then is 12 grams per mole. So this leads us to a conclusion that's really helpful for us. The molar mass of a substance in grams per mole is numerically equal to the atomic, molecular, or formula mass of that substance in atomic mass units. So all that work we did on calculating atomic mass units, right? Formula mass, all of those things, they all are directly transferable here, okay? So it's pretty much the same thing. So let's do some examples. So they're numerically equal. Before we do that though, here's just a bunch of compounds with all of their molar masses listed here in grams per mole. So the different substances, of course, have different masses and, you know, lots of cool colors and different things listed here. Not so important, but just to give you an idea what we're talking about. Okay, so moving on from that, let's do an example. So remember, the molar mass is numerically equivalent to what we were calculating before for formula mass, just the units are different. So let's do this problem together, and we're going to use dimensional analysis. So what is the mass of a mole of ammonia? And it gives us our formula here for ammonia molecules. Okay, so 1 mole of ammonium molecules, or ammonia, excuse me. Okay, so using dimensional analysis, here we go. Let's write down what's given. We're given 1 mole, right? A mole. We want mass in grams, okay? But what is my per expression here? How do I find that? Well, what you're gonna do is you're gonna calculate the molar mass of this molecule, okay? So what we do, let's write down how many of each atom we have, similar to before, okay? Whoops, give me a second. We have 1 nitrogen and 3 hydrogens. Then you go in the periodic table and find the masses of each one of these atoms or elements. Okay, you multiply those together. Add them up. Okay, and this now, remember, the molar mass is numerically equivalent to formula mass. So the only difference is the units here. So actually, we're going to change this unit to grams per mole. Okay, this unit is in grams per mole here because we're referring to molecular mass. Okay, so the unit is in grams per mole of this molecule. So that means my per expression here going to be 17.04 grams per mole. Okay. So let's write out this equation. You could probably do this one in your head, but I just want to show it so that we're all clear on what we're going to do later. So 1 mole times 1 mole NH3. And I should actually write that here. This is not just 1 mole, it is 1 mole of NH3. Okay, times 17.04 grams equals 17.04 grams, okay? So that's our answer right there. So that's how we're going to calculate the mass of a mole of a substance. So in the next video, we're actually going to be doing more conversions and converting between molecules and mass and moles. So see you then.